Imagine pouring billions of dollars of liquid capital directly onto bare dirt, hoping a fraction of it hits your actual target. For decades, the global agricultural sector accepted this massive inefficiency as an unavoidable cost of doing business, blanketing entire fields with expensive chemicals to eliminate a small percentage of weeds. This broadcast methodology represented a staggering waste of enterprise resources, severely compressing profit margins for massive farming operations and introducing immense environmental liabilities. You are looking at an industry ripe for ruthless optimization, waiting for a technological catalyst to shatter the status quo. That catalyst did not emerge from a Silicon Valley startup, but from a legacy manufacturer that fundamentally redefined its entire corporate identity. John Deere engineered a masterclass in enterprise evolution, orchestrating the transition of industrial hardware giants into AI-driven software platforms. They recognized that the future of heavy machinery was not about building bigger engines, but about embedding profound intelligence directly into the iron. By pivoting their strategic focus toward advanced computation, they transformed their core value proposition from mechanical horsepower to algorithmic precision. The cornerstone of this aggressive market repositioning is their See and Spray technology. This is not a superficial digital overlay, but a deeply integrated application of real-time computer vision deployed in the harshest physical environments imaginable. The system utilizes dozens of high-resolution cameras mounted along massive carbon fiber booms, scanning the ground with relentless accuracy as the machinery moves through the field. It represents a paradigm shift in precision agriculture, where automated decision-making occurs at the exact point of physical contact. The immediate economic impact of this integration is nothing short of revolutionary for the end user. By precisely identifying and targeting only the invasive plants, this system reduces herbicide usage by up to 77%. For a commercial farming enterprise managing tens of thousands of acres, that translates into millions of dollars in recovered capital previously lost to chemical waste. This tangible return on investment immediately shifts the purchasing conversation from capital expenditure on a vehicle to a highly lucrative operational efficiency upgrade. Executing this level of precision requires extraordinary localized processing power. When a 10-ton tractor drives across uneven terrain at 12 miles per hour, the artificial intelligence must capture image data, differentiate between a valuable crop and a destructive weed, and trigger a specific pneumatic nozzle all within 200 milliseconds. The margin for error is absolute zero, as a false positive destroys the revenue-generating plant, while a false negative allows the threat to proliferate. This technical reality forces a profound strategic realization for any executive operating in the physical world. The vehicle itself has become merely a delivery mechanism for a highly sophisticated edge computing network. The metal and hydraulics are now secondary to the localized neural networks that execute complex cognitive tasks without relying on a constant cloud connection. When you operate in rural environments where bandwidth is non-existent, your artificial intelligence must be entirely self-sufficient at the edge. This localized autonomy creates an impenetrable defensive moat against potential market disruptors. Every single acre scanned by these machines feeds back into a proprietary data ecosystem, creating a massive network effect that competitors simply cannot replicate. The algorithms become exponentially smarter with every passing season, trained on billions of images of diverse plant species under every conceivable lighting and weather condition. This is how legacy companies leverage their existing physical footprint to build insurmountable data advantages. By commanding this proprietary data pipeline, the company successfully transitioned from selling depreciating assets to selling continuous agricultural outcomes. Customers are no longer just buying a piece of heavy equipment, they are subscribing to an intelligent platform that guarantees specific yield protections and cost reductions. This shift fundamentally alters the relationship between manufacturer and operator, locking in long-term enterprise loyalty and generating highly predictable recurring software revenue streams. The initial echoes of those early data hurdles still resonate within their engineering divisions. Training a convolutional neural network to differentiate between a soybean plant and a visually identical weed species required an unprecedented volume of meticulously annotated training data. Early iterations struggled with the chaotic variables of the physical world, from harsh shadows cast by the machinery to the rapid movement of leaves and heavy winds. To conquer these variables, they deployed massive synthetic data generation and aggressive machine learning pipelines. They built digital twins of agricultural environments, simulating millions of lighting conditions and plant variations to aggressively stress test their models before field deployment. This relentless focus on robust algorithmic training ensured that the system could generalize its knowledge across wildly different geographies and crop types, proving that enterprise AI must be battle-tested against extreme edge cases. Integrating these trained models into a commercial product required a radical overhaul of traditional manufacturing processes. The company had to seamlessly fuse delicate silicon processors, advanced optics, and ruggedized cooling systems with heavy industrial steel designed to withstand extreme vibration and dirt. This convergence of software engineering and heavy manufacturing serves as a critical blueprint for any organization attempting to bridge the gap between digital intelligence and physical execution. The successful execution of this hardware and software synthesis redefines what it means to be an industrial market leader. You can no longer afford to operate isolated engineering silos where the software team and the mechanical team rarely interact. True market dominance in the modern era requires absolute structural alignment, where artificial intelligence dictates the physical design of the hardware from the very first blueprint. This holistic integration completely marginalizes traditional competitors who still view technology as an optional aftermarket add-on. When an entire machine is architected around a central nervous system of computer vision, the resulting performance metrics shatter the ceiling of what dumb iron can achieve. Competitors attempting to bolt third-party software onto legacy hardware simply cannot match the millisecond latency and seamless execution of a natively integrated AI platform. The compounding financial benefits for the customer extend far beyond the initial chemical savings. By reducing the volume of harsh herbicides applied to the soil, the underlying crop experiences less chemical stress, leading to a measurable increase in overall harvest yield. This dual action value proposition simultaneously slashes operational expenses while driving top-line revenue growth, creating an irresistible economic argument that rapidly accelerates market adoption. To maximize this market penetration, the strategic deployment involved bringing this capability to both brand new flagship models and existing customer fleets. By engineering backward-compatible retrofit kits, they rapidly expanded their total addressable market, allowing operators to upgrade their current assets with cutting-edge intelligence. This aggressive deployment strategy ensured that the advanced technology penetrated the market at an unprecedented velocity, rapidly expanding their active data collection footprint. This rapid expansion effectively corners the market on precision agricultural data, establishing an unshakable monopoly on field-level insights. The sheer volume of visual information processed by this global fleet provides an unparalleled understanding of global crop health, weed resistance patterns, and soil conditions. This positions the manufacturer not just as a tool provider, but as the central intelligence hub for the entire agricultural supply chain. The trajectory of this technological deployment points directly toward fully autonomous farming ecosystems. The computer vision capabilities currently utilized for precision spraying lay the foundational architecture for heavy machinery that navigates, analyzes, and executes complex tasks without human intervention. We are witnessing the incremental construction of a robotic workforce capable of managing millions of acres with perfect algorithmic consistency. The lessons embedded in this industrial transformation are universally applicable to any C-suite executive navigating the artificial intelligence revolution. Your legacy physical assets, your established distribution networks, and your captive customer base are not liabilities. They are the exact leverage points required to deploy AI at scale. The organizations that win the next decade will be those that weaponize their physical footprint to capture proprietary data. To replicate this success within your own enterprise, you must ruthlessly audit your core operational processes for areas of massive resource inefficiency. You must identify the specific points where automated, real-time decision-making can eliminate waste and dramatically enhance the final output. Once identified, you must aggressively invest in the localized computing power and specialized models required to execute those decisions at the absolute edge of your network. Driving this level of transformation requires overcoming immense internal inertia and legacy corporate culture. You must actively dismantle the outdated belief that your company simply bends metal or moves physical goods. You must force a cultural re-education across your executive team, demanding that every new product initiative begins with a clear strategy for data acquisition and algorithmic optimization. The window for initiating this fundamental pivot is rapidly closing across all sectors of heavy industry. As early adopters solidify their software-driven moats and lock in long-term customer contracts, the barrier to entry for latecomers becomes mathematically impossible to overcome. The future belongs exclusively to the organizations that successfully fuse the physical reliability of industrial hardware with the relentless scalability of artificial intelligence. You stand at the exact intersection of mechanical legacy and digital supremacy. The blueprint for aggressive automation, dramatic scaling, and decisive market dominance is proven and currently operating in fields across the globe. It is time to stop viewing artificial intelligence as an abstract concept and start engineering it directly into the very core of your industrial engine.